Something on your Linux box just broke and you've got a terminal open. Let's fix it together. Over the next few slides, we'll walk through 8 real-world failure scenarios. A disk that's full or throwing I/O errors, a service that refuses to start, a network that's gone silent, and permissions that won't let you in. For each one, we'll follow the same loop. Observe the symptom, isolate the cause, diagnose with the right command, and apply a clean fix. That loop deserves a closer look because it's the backbone of everything that follows. Step 1. Observe. Pin down exactly what's failing in precise terms. Step 2. Isolate. Narrow it to a layer. Is it the disk, the network, the service, or permissions? Step 3. Diagnose. Find the actual root cause, not just a symptom. And step 4. Fix. Apply the change and verify it worked. The golden rule throughout. Change one thing at a time and retest. Touch 5 things at once and you'll never know which one actually helped. With that loop in mind, here's the toolkit you'll reach for first on almost any Linux box. Start with journalctl for recent system logs and errors, then SysAdmin status to check if a specific service is actually running, and DFOH for a quick read on disk space per file system. On the resource side, free H shows memory at a glance, top or htop reveals what's eating CPU and RAM, and DMESG surfaces kernel, and hardware messages with readable timestamps. 6 commands, that's your observation layer. Let's put that toolkit to work on our first scenario, a full disk. The symptom is unmistakable. Writes fail with no space left on device, and apps start crashing or refusing to launch. To diagnose, start with DFAH to spot which file system is full. Then do XH piped into sort RH and head to rank the biggest directories and find BZIs, beside 500 malware to flush out the individual large files. For the fix, work from safe to surgical. journalctl, vacuum size, 200 trims system logs. apt clean clears the package cache, and only then do you RAM the specific big file you identified. Scenario 2, a service won't start, saying Linux is down and the site is offline. Same loop applies. Diagnose with SysAdmin status enjoy X for a quick verdict. journalctl XE for the detailed log lines around the failure, and enjournalctl to validate the config itself. 9 times out of 10, the error message names the file end line. Fix it in your editor, then systemstable restart nginx to apply, and systemtl enable nginx so it comes back on the next boot. On to scenario 3, no network connection. The trick here is to work outward, layer by layer. Start with IP adder. Do you even have an IP on the interface? Then IP route to confirm there's a default gateway. Finally, ping 1.1.1.1 to see if traffic actually leaves the box. Wherever it breaks, that's your layer. To fix, bring the interface up with IP link set ETH0 up, or let Network Manager handle it via nmcli conup ETH0, then retest with another ping. Now scenario 4, and it's a classic. Pinging 0.1.1.1 works, but google.com goes nowhere. That tells you the network is fine. It's purely name resolution. Confirm it with a quick ping to both, then check resolve CTL status to see which DNS server you're actually using. To fix it, point the connection at a known good resolver with an nmcli conmod ETH IPv DNS 1.1.1.1, then verify with google.com. Scenario 5, permission denied. Something can't read, write, or execute a file, and the question is always the same. Who are you, and what does the file actually allow? Start with LSL to see the owner, group, and mode bits. Run ID to confirm which user and groups you're operating as, and use name or ID on the full path to catch a parent directory blocking access. Once you know the gap, close it deliberately. Alkojmod +6 to make a script executable, chound a hand ownership to the right user and group, or chmod 644 to set sane read permissions on a regular file. Scenario 6, high CPU and load. The machine feels sluggish. The fans are spinning, and you need to find the culprit before doing anything drastic. Open top and press P to sort by CPU usage. Glance at uptime for the 1, 5, and 15-minute load averages, or pipe piezo through sort to surface the heaviest processes. Once you've identified the runaway, you've got options. Release Pl110 to lower its priority and let the system breathe. SysMPTOM restart to give the service a clean slate, or kill 15 to send a polite termination signal. And then dig into the logs to find out why it happened. Scenario 7. Out of memory. When processes start getting killed and DMESG shows the dreaded out-of-memory killed process line, the kernel's killer has stepped in to save the system. Start with free AH to see how much memory and swap you actually have left. Then DMSG pipe through grep, to confirm what got reaped and when, and PSOX sorted by memory to find your top consumers. The fix depends on the cause. SysAdmin restart the offender if it's a leak you can't patch right now, or buy yourself headroom by carving out a swap file with Fallocate and bringing it online with SysAdmin. Scenario 8, the machine won't boot, or it comes up with the root file system stuck read-only. First, find out why. Journalctl bprr pulls every error from the current boot. DMESG pipe through grep. error surfaces kernel complaints, and mount pipe through grep will confirm which file system is read-only. Once you've spotted the bad disk, run fsec on it, unmounted ideally. Then remount with mount remount. W to bring it back online. And while you're there, check door etc. sfstab for typos, because a bad entry there will drop you straight back into the emergency shell on the next reboot. Speaking of finding the why, most of the time, the system has already told you what went wrong. You just need to know where it wrote it down. Start with journalctl xe for the system journal, or narrow it to a single service with journalctl isolu. On Debian and Ubuntu, the catch-all is var log sizelog. On RHEL and Fedora, it's var log messages. DMESG gives you kernel and hardware events with readable timestamps, and var log auth log is where logins and sudo activity live, invaluable when something security-related is off. Once you know where the logs live, you need a routine for actually using them. Here's the triage flow I run every time something breaks. First, dibh to check if the disk is full. That one catches more outages than you'd think. Then systemctl status to confirm the service is even running. Next, IPA and IPR to verify there's an address and a route out. Then dig to check DNS resolution. And finally, journalctl xe for the story behind it all. The first question that answers no is your problem area. Stop there and dig in. Now, before we go further, let's talk about the habits that turn small problems into big ones. Changing many things at once is the worst offender. Even if it works, you've learned nothing and you may have introduced new bugs. Ignoring the logs is just guessing with extra steps. The answer is usually right there in the error message. Rebooting first can mask the real cause and burn your uptime. And never edit a config without a backup. A quick CPA file. Back takes 1 second and saves you hours. So let's flip that around and look at the habits that actually work. Read the error carefully. 9 times out of 10, the message tells you exactly what's wrong. You just have to slow down and look. Change one thing at a time, then retest so you know which change did what. Back up before you edit anything. cpconfig config back every time. And when you find the fix, write it down. Future you at 2 in the morning will be very grateful. And speaking of writing things down, here's a cheat sheet worth keeping close. Group these by what they answer. For resources, DFH for disk, free H for memory, and top or HTOP for CPU and RAM. For services and logs, systemctl status tells you if something's running, and journalctl xe shows you why it isn't. On the network side, IPA and IPR give you addresses and routes, and dig tests DNS. And for the rest, LSL and ID for permissions and identity, and DMESGT when you suspect the kernel itself has something to say. And here's the full tour in one view. The 8 scenarios we've worked through. Disk full, we go df do rm. Service down, systemctl status into the logs. No network, IPA, IPR, ping. DNS failing, resolvectl. Permission denied, lsbl, then chmod or chown. High CPU, top then kill or release. Out of memory, free, check for the killer, restart. And won't boot, journalctl b, then fsk. Same loop every time. Observe, isolate, diagnose, fix. So if you take nothing else away, take these 4. Be systematic. Observe, isolate, diagnose, fix, never random guessing. Go to the logs first. Journalctl and var log almost always hold the answer. Change one thing at a time and retest so you actually know what fixed it. And triage in order as disk, service, network, DNS, logs. The first no you hit is your clue. Before we wrap up, here's a quick reference to keep in your back pocket. Load average is the count of processes waiting to run, averaged over 1, 5, and 15 minutes. The killer is what the kernel reaches for when memory's exhausted. A read-only file system usually means something went wrong, and it remounted defensively. That's when FSCK comes in to check and repair. The journal is system's central log store reached through journalctl and exit codes. 0 means success. Anything else points to a specific failure worth looking up. So here's the whole idea in 2 lines. Don't guess, diagnose, and fix. Every Linux problem leaves a signal somewhere. In a service status, a log line, an exit code. And your job is to follow the evidence and change one thing at a time. If you want to go deeper, there are courses, cheat sheets, and CLI tools waiting for you at dargslan.com. Thanks for watching. Subscribe, like, share, and I'll see you at the terminal.